Hello, welcome to the department. My name is Xuefeng Zhang, a assistant research professor from the Department of Sustainable Bioproducts. Here is our department, the main building, Clean Furniture Institute. Today I will bring you to my lab and introduce my research to you. So please follow me. Recently, we are developing a technology to convert this normal paper, which is hydrophilic and is not water durable, and convert to a hydrophobic one that it can withstand a water. So, and the process is very simple, as she will show you. For this one, it's a small piece of square. It's the conventional paper, like craft paper we are using, right, for the, if you go to supermarket, for the packaging, and then immerse this into the solution for certain time, and take it out and dry it. And after this process, this paper will turn from hydrophilic to hydrophobic, which means you cannot wet paper by water anymore, not easily. And it's made from left one is made from the paper without modification. You see, they are sink down because they are taking water quickly. And the other one is the hydrophobic paper that we modified. As you see, they are pretty stable. And actually, it has been staying here for 2 months. This is a lab. We have many, as you see, we have many equipments here. So this is where we're doing materials analysis. So as you know that we work on the wood modification and making biomaterials. Basically, after this treatment, we want to know what happened in the wood. Like for example, this FTIR, they will tell you, okay, which component has changed, like cellulose, what's the change. Let's go to my office and I will show you something of my products. So I had a bachelor's and a master's degrees in wood science and technology from the Nanjing Forest University, China. During my bachelor's and the master's study, I participated in several research projects, including wood modification and wood identification, and also some wood property evaluation. And during that process, I also assisted many companies to evaluate their products to help them improve their process. I would say that's where I discovered my interest in this wood science and bio-based material area. After I completed my master's degree, I decided to pursue a PhD degree. I was lucky to get a research assistantship from here. I have been working at MSU for almost 9 years. So I come here as a PhD student in 2013, and 3 years later in 2016 I completed my degree and I joined another research group and as a postdoc research associate, and I worked on 3 projects. And in 2020 I was lucky to get promoted to a research assistant professor. Our department is actually do a lot of things. We directly make wood construction buildings using the lumber and timber products with composites. It's the first thing and the most important thing we are doing. We also make biochemicals and biofuels from wood. You may hear like biodiesel and biogasoline, biomass based. Yeah, we are working that as well. Also try to consider wood as a polymer, bio-based polymer material, to convert it into bio-based plastics. We make a carbon from wood. With the increase of these environmental issues everywhere in the wood, we try to reutilize old material for new way. My most favorite part is the research of what I'm doing, and I am currently developing a different functional materials from wood, and I taken wood cellulose to make packaging materials that can replace these traditional plastic-based films. But you know, plastic is non-degradable, and but this paper-based one could be degradable. And I also take another component from wood, which is lignin, and to make some plastic forms, adhesives, and coatings. Another most important thing I like here is the people. People here are very nice and very kind and very helpful. At the same time, our graduate students are very motivated and very productive. So my research interest is the development of bio-based materials for environmental and engineering applications. Specifically, I would like to produce the bio-based and biodegradable plastics from wood, from tree, and that can reduce the use of conventional petroleum-based plastics and decrease the plastic pollution issues. I'm currently working on the multiple USDA-funded projects that including the development of bio-based component materials for water treatment and soil remediation, basically removing contaminants from the soil, including those nutrients and also heavy metals. And I'm also working on the development of hydrophobic paper films for packaging applications. Now modified one, and this is a modified one which is hydrophobic. So this is water. Okay, non-toxic is fine. So if you look here, so they're getting wet, and they're very soft. I mean, if I touch them, they will broken. They're getting wet because they're absorbing moisture, water. So this is a modified one, as you see. So they're fully fluid soil. So that's why this technology is important. So it's simple, but we can make this papers more useful. Think about a situation. If you have this paper, have some products, right? If you go to the grocery store and buy some fruit, and it's raining outside, when the paper packaging gets wet, they are broken. So, but this one, they are durable. I would like to collaborate with industries to promote our technology from the lab, such as this hydrophobic paper, which is durable and which is water resistant for real applications. So, and I'm looking for industry partners for that. That my current technology of this hydrophobic paper packaging material is the most exciting thing that I have developed in MSU. Now I have discovered a new and simple technology that can convert this normal paper we are having every day just by dipping and immersing and dry from the hydrophilic and the low water strength to a hydrophobic with a high water resistance and high water strength. So I'm expecting to see that this technology can be used in the near future. Yeah. I think the deepest challenge of developing our current technology, hydrophobic packaging paper, is fundamental science behind the technology. And I show you in the lab that you see they are durable and the method is simple, but I working very hard with my student to understand what really happened on the molecular level of that material, of cellulose, of the paper. So currently we have a really good process, and we need to collect more data to validate the concept we are doing. You know, resource depletion and environment pollution is an issue, and the people try to pursue this sustainability and biodegradable. So, and at the time I start to think about, okay, can we convert this wood to something could be very useful and by used differently? I feel that you know what I'm working on is very useful because they're not only for wood. They can matter a lot. They can, you know, wood can be used to produce biofuels. They can decrease our dependence on these petroleum-based resources. And also, US have a lot of first land, and how to increase the value to make some high-value products is my goal as well. So I feel this is how my research and how the research we are doing here gonna affecting the outside of the MSU. The great teams will make the research productive. So I think our university does a very good job to provide this environment. So I think MSU did a really good job from those 3 different sides of people, environment, and also a lot of training and workshops, and also there are a lot of supporting staff like you guys that all together like making this a really good place to do research.